Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is based on electronic devices. In this 1 mark and 2 marks questions are being discussed. Most of these questions are board questions, previous years board questions. First question, what happens to width of depletion layer of PN junction diode when it is forward biased? What is forward biased? Forward biasing means when this P region of PN junction diode is connected to positive and N region is connected to negative. P to P and N to N. Here P is connected to positive and N is connected to negative. Now in forward biasing, what happens? Width of depletion layer will decrease. What happens to width of depletion layer of PN junction diode when it is reverse biased? Reverse biasing means now this P region is connected to negative terminal and N region is connected to positive terminal. So P is connected to N and N is connected to P. Like this, we can memorize the things. Here, the width of depletion layer will increase in reverse biasing. What happens to barrier potential in case of PN junction diode if it is forward biased? When it is forward biased, barrier potential will decrease. When PN junction diode is reverse biased, what happens to barrier potential? It will increase. How does rising temperature of semiconductor affect its resistivity? We know that semiconductors are conducting at high temperature, but these are acting as insulator at low temperature. So when temperature is increased, what happens? More and more charge carriers are available in conduction band because of breakage of some covalent bonds due to thermal agitation. So conductivity will increase and resistivity will decrease. So resistivity decreases with increase in temperature as more charge carriers are available at high temperature because of breaking of some covalent bonds due to thermal agitation. Now in this diagram, which bulb will glow? We know that only that bulb will glow which has current flowing through it. Now, here 2 diodes are there. That means diode should conduct in that case. So let's check. Here P is connected to positive, N is connected to negative. So it is forward biased. And when diode is forward biased, it conducts. So this part of the circuit will conduct. But here in D2, this N is connected to positive and P is connected to negative. So it is reverse biased. When diode is reverse biased, it will not conduct. So this part is not conducting. That means only D1 will conduct, as a result of which V1 will glow. Because V1 is forward biased and when diode is forward biased, it conducts. What do you mean by doping? Doping is the process of adding impurity atom from outside deliberately into pure semiconductor. Now, what are pure semiconductor actually? Pure semiconductors like silicon and germanium. These are intrinsic semiconductors because the charge carriers are provided from inside. So, such semiconductors have low concentration of charge carriers. So, to increase that concentration, doping is done. Doping means to add impurity atom from outside deliberately into pure semiconductor. And it is done to increase concentration of charge carriers in case of semiconductors. What is rectifier? Rectifier is a device which converts AC into DC. Write the principle on which its working is based. Actually, diode acts as rectifier. So diode will conduct only when it is forward biased and does not conduct when reverse biased. So this is the principle on which rectifier is based. So rectifier is a device which converts AC into DC, and because diode acts as rectifier, it conducts when forward biased and does not conduct when reverse biased. This is the principle of working of rectifier. Draw well-labeled energy band diagrams for P and N type semiconductor. Now in semiconductor, what happens? Like germanium and silicon, forbidden energy gap is present between this valence band and conduction band. This energy band is not so much. It is less than 3 electron volts. So charge carriers are easily available in conduction band on thermal agitation. Now, because charge concentration is less in pure semiconductor, so those semiconductors are doped. Means some impurity atoms are added from outside. If number of holes is more than electrons, then P-type semiconductor. If number of electrons are more than holes, then N-type semiconductors are formed. And P-type semiconductors are formed by adding trivalent impurity, and N-type semiconductors are formed by adding pentavalent impurity. When we add boron, which is trivalent impurity in germanium, what happens? One of germanium is replaced by boron. Then boron has 3 valence electrons. So it forms 3 covalent bonds with 3 neighboring germanium atoms, but 4th covalent bond it is not able to form with 4th neighboring germanium because of deficiency of electron. So hole is created. Hole means deficiency of electron, and it has positive charge. So as a result of which empty energy level is created just above valence band. Now what happens? When electrons from this valence band jumps into this acceptor energy level, then hole is created here, and that hole is filled by neighboring atom by breaking covalent bond. This hole takes up electron from this and leaving behind hole. In this way, hole conducts in valence band because of movement of electrons from valence band to acceptor energy level. But in case of N-type semiconductor, what happens? Pentavalent impurity is added. When one of such impurity is replacing germanium, then 4 covalent bonds are formed with neighboring 4 germanium atoms, but 5th electron is more in case of pentavalent impurity like arsenic. That electron will be more and will act as free charge carrier and will exist in energy level created just below conduction band known as donor energy level. So this is full of electrons. These electrons jump into conduction band, helping in conduction by gaining some little bit energy. So to draw P-type and N-type semiconductor energy band diagram, it will be like this, that just above valence band, there will be a acceptor energy level which is empty. And in case of N-type semiconductor, just below conduction band, filled energy level will be there, known as donor energy level. What type of impurity atoms are added to intrinsic semiconductors to make N-type and P-type semiconductors respectively? Intrinsic semiconductor means germanium and silicon. When we add trivalent impurity, then hole is created. So number of holes are more than electrons. So it will act as P-type semiconductor. So P-type semiconductor is formed by adding trivalent impurity like boron. This is the example of impurity atom. And N-type semiconductor, electrons are more. That means we are putting that impurity atom which is giving extra electrons. So pentavalent impurity is added to make N-type semiconductor. Examples of impurity atom are phosphorus and arsenic. Thanks for watching this video. Like, share, subscribe my channel.